Hey everyone, how you doing today? Wazoo here, and in this tutorial we are going to take one of my existing projects, which is the Asteroids game that you see in front of us, coded in C, and translating it to using the Python RayLib bindings. So translating it to Python. Yeah. This is the quote-unquote final version of what we'll be building. As you can see, the sound effects are the same, and the motion, collision detection are all the same. So I thought it would be more or less a one-to-one translation of the C project, but just done in Python. Yeah. I was curious to see how it would translate and how the Python bindings would work out. So yeah, if you haven't used RayLib before, it is a game programming framework library. Kind of, I guess it's kind of a library. It's more of a library than a framework. Basically, what any good library does is it provides some higher level functions to implement lower level details. And so we've been using it on a few projects on this channel, and so I thought just for fun, it would be really great to tackle this for Python. So I'm going to assume that you have Python 3 installed. You don't need anything else other than Visual Studio Code and Python 3. And so first things first, let's get to a new folder. I'll just create a folder called Python RayLib Asteroids. Okay. And then let's go into that. And Python has this, I'm going to call it goofy because it feels kind of goofy, but Python has this ability to work in a sandbox, which it calls a virtual environment. And pretty much every best practice and every tutorial for Python out there recommends that you create your application within this virtual environment in Python. And so how you create one is you type in Python-m and then virtual environment venv, and then you give it a name. And in this case, I'm just going to use the same name. So venv. Very imaginative. So it's going to go off and do its thing. And then you'll see in your folder that you've got a new one called venv. So first things first, let's just pop this open in Visual Studio Code. Okay, and so what ends up happening in the venv folder, let's show what it looks like here. Okay, that's nice and huge now. So we've got there's a scripts folder in the virtual environment folder, and it has a few scripts, activate and deactivate, along with pip3, and even some Python files. So we are going to activate it. So type in, okay, so go into the scripts folder and then just run activate. You'll notice in your terminal window that your file folder, the current file folder, has a VNV prepended text there. And that just gives you a little visual indicator that you're within a Python virtual environment. So let's go ahead and install the RayLib Python bindings along with the library called NumPy, which we'll need. It's a Python library that handles math. So let's type in pip3, or just pip install. Oh, we'll have to go back to our root folder. Sorry about that. So back in your project folder, we've backed out of the venv folder. So now just type in pip install RayLib and NumPy. And so it'll go off and do everything. It'll do all the work. Okay, and then what we want to do is we want to freeze those into a requirements.txt file. A requirements.txt file is very similar to a pom.xml file, to like a Java project, or a package.json file for a JavaScript project, or a gem file in a Ruby on Rails project. It's kind of a way of tracking project dependencies. All we have to do is type in pip freeze -l bigger than, and then requirements.txt. Okay, so now we've got a requirements.txt file in the root of our project, and you can see that we've got the version numbers of the libraries, the dependencies that we're using. So in this case, you can see that we're using RayLib 5 and NumPy 1.26.3, along with a few other ones. In the root of our project, let's just go ahead and create a Main.py file. Okay, and this will be our main entry point into our application. Even though I'm not a Python developer by day, I wanted to try and structure this in a bit of an object-oriented way, or at least as much as you can with Python without looking too crazy, I feel. But there's always room for optimization. There's always room for improvements. So feel free to leave a comment down below if you see something that I'm doing in this video and you say, hey, wait a minute, there's a better way to do this in Python. Okay, so first of all, we're going to import PyRay as PR. And so PyRay is the RayLib Python bindings. And then we're going to create two variables to match what we had in the C code. So screen width is 1280 and screen height equals 720. And now we're going to create a Python main function, which looks something like this. If 2 underscores name equals underscore underscore main underscore underscore end string quote colon. And we are going to create the window, so PR init window. And then we'll pass in screen width, screen height, and then we'll just give it a name. So Python Asteroids, whatever, Python Asteroids. Okay, and then we're going to set the target frame rate to 60, as we did in the C project. And then we're going to go right away into our main loop. So while not PR window underscore should underscore close, we want to update the game, and then we want to begin underscore drawing. We want to call begin underscore drawing, and then PR dot clear underscore background, and use it, clear it to black. And then we want to PR end underscore drawing. And finally, we want to end the while loop with a PR dot close window. Once we're exited the while loop, we call PR close window. And this is the end of our main function. So all of the API calls to the RayLib library, that RayLib cheat sheet. So on the RayLib website, there is a easy to find RayLib cheat sheet with all of the C functions. And so for this Python binding, all you have to do is replace, basically lowercase, all of these function names and put underscores in between these function names. So for example, get screen width, it would be lowercase get underscore lowercase screen underscore lowercase width, and etc. It would be the same way for all of the other functions. But this is a good handy reference point as it is for working in on the C side. Okay, so let's go back into our terminal here, and I'll show you what the virtual environment is doing for us. So we've installed all the dependencies into requirements.txt. We're currently in our virtual environment. So if I type in Python main.py, it should create a new window, empty window for us, clearing the screen to black of 1280 by 720. And if I hit escape, it should then exit, and it'll say window closed successfully. Okay, so we've got our main loop going, and I wanted to try and create something very similar to the C version where we had the startup, update, render, well, game startup, game update, game render, game shutdown, and game reset functions. I wanted to stick them all into a game class that Python lets you create. So let's go ahead and create a file here called game.py. And at the top, we're going to import PyRay as PR again. Let's see, so let's get started. So let's create a new class. So use the class keyword and then call it game. And then we are going to create the constructor function, which is def underscore underscore init underscore underscore. And then to all of the functions in a class, you want to pass self as the first parameter. And then that way you can work with the variables and references that are assigned to that class, to the instance of that class, sorry. So we're going to pass in the screen width and screen height into the constructor. And we are going to be creating a resources set, which is basically like a JSON object or a hash object if you're used to Ruby. This will be where we'll stuff all of our assets, so all of our images and our sound effects. And then that way we can reference them just by passing in a key. And then we'll create a meteors array, shots array. Python seems to use list instead of array. So I do apologize in advance. I might reference them as arrays when in Python lingo they're called lists. So I hope it doesn't confuse too many people. And let's see, let's save the screen width and screen height into self.screenWidth and self.screenHeight equals screen height. Okay, and then let's create what we're going to do is create our empty functions. So instead of game startup, since we're already in the game class, I'm just going to call the function startup. So startup, and don't forget we need to pass in self, and we can just use the special keyword pass, which basically is like a no-op for that function, and that lets the function instance itself and run when we want to test everything else first. Okay, so we've got startup, and now let's create a def update. And we'll also pass in self. And similarly, we'll have the pass. Okay, and then we'll create a function called render, self, and also pass, and a shutdown, self, and pass as well. Okay, and then from the Main.py, oops, I forgot to put a colon at the end of the init function there. Okay, so at the top of your main.py file, underneath the import pyray as PR, we can say here from game, import game with a capital G, because that's what we call the class. And then right underneath our screen width and screen height declarations, we can create a current game equals game, and we're passing in the screen width and screen height. So this should call that constructor method, and then that means right after the PR set target FPS, we can call current game startup, and then right within the while loop, we can call current game update, and then after we clear the background, in between clear the background and end drawing, we can call current game.render. And then finally, after the close window, we can call current game.shutdown. Okay, pretty standard stuff. Now in the startup method, remember in our C version of this program, we called the init audio device function to prepare the audio device subsystem in RayLib. So let's do the same thing here. So we'll call PR init underscore audio underscore device. And then in the shutdown, we'll call PR close audio device. And then what we're going to need to do is we've got an entity, what we defined as an entity in our C project for our meteors and our player object. So let's create the same thing here in Python. Let's create a new file and we'll call it Entity.py. And again, we'll import pyray as PR. And then we'll create a new class. We'll call it Entity. And we'll create a constructor method. So def underscore underscore init underscore underscore self. And we will have the same attributes. So self.position equals PR vector2 0 0. And a self.speed of PR vector2 0 0. We're going to have a heading, our heading property, and that will be 0.00. And we're going to have an acceleration, 0.00. And we're going to have an active flag, so active equals false by default. And then a type to just be 0. Okay, so then in game, we can, at the very top underneath the import of PyRay, we can import from entity, import entity with a capital E. Okay, and then right after self.shots in the constructor of game, we can type in self.player equals entity. So basically call the constructor for our entity function for the player, or entity class, sorry, not function. Okay, and then if you recall in our startup function on the C code, we also ended things with a reset, a call to reset the state of all of the meteors and the player, etc. So we'll call the same thing here, self.reset. And then underneath the shutdown function, let's create another one called reset. And then let's go ahead and start updating that. Okay, so we've got our shots and meteors lists, and we want to clear those of any existing shots or meteors. So we just call self.shots.clear and self.meteors.clear. Okay, and then we want to initialize our player. So self.player.heading equals 0.00, just in case. Self.player.acceleration equals 0.00. We want to self.player set the active flag to true. And we want to set our speed equals PR vector2 0 0. So it's almost a little bit of a rehash of what we did in the initialization of entity, but I thought I would just make sure that things are being properly reset here to match kind of what we did on the C side. Okay, and then for the position, we created a new vector2, so pr.vector2. And we took the screen width, so self.screen width, and then we need a double divide sign by 2, and then a self.screen height double divide by 2. In Python, it looks like you have to use the double slash as the divisor operand. So we will do the same thing here. I do recommend for this project that you check it out from GitHub before we work on it. At the very least, download the zip file, because then you can just use the assets that are in the project and put them in this folder. Okay, so in this project, I've copied all of the assets over from the existing Asteroids C project. So you'll see there's a folder here called Assets with our laser explosions and our meteor texture images and the player texture image. So let's go ahead and load those up. And if you recall, on the C side of things, we tried to use an enum in order to easily reference the textures and the audio files. Remember how we created that resources object to do that with. So again, back on the Python side, we can use a enum as well in Python. So let's create a new file here that we're going to use from game. And this new file will be called resource_type.py. And we're going to be importing enum. And then we'll create a new class called resource type and pass in enum.enum in the constructor. Well, not really constructor, but as into this class. So we're going to be using the same names. So texture meteor _small equals 1, and then texture meteor _med equals 2, texture meteor _large equals 3, texture player equals 4, and sound laser shoot equals 5, and then sound underscore laser underscore explosion equals 6. So that's all we need to do there. And let's go back into the game.py, and then import this resource type. So the very top after the entity, we can just declare from resource type import capital resource type. Okay, and let's see. So let's go into our startup function. So after we initialize the audio device, let's go ahead and create our image, loading our images and loading our audio files. So we can say image equals pr dot load underscore image, and then we want to load it from assets slash meteor underscore small dot png. And then what we want to do is into the self dot resources resource type texture meteor small. So remember that this is a set, and we're creating a key of resource type texture meteor small, and then that's where we're loading the image to. pr load underscore texture from image, and then pr dot unload underscore image. Okay, so we're loading the image with the pr dot load underscore image and giving it the name to our image file. And then we are converting that image into a RayLib texture object. And we are stuffing the result of that in the resources, dictionary, hash table. There's a few different, again, kind of like list and array. I'm going to be intermixing the two terminologies a little bit. So I might call it set or hash or object when it's also a dictionary in Python lingo. So we can cut and paste this a few times because we're just going to be loading up the different textures. So just remember to change the file names. So meteor underscore mead is equal to texture meteor mead, and then meteor large, texture meteor large. Okay, and then we have the player, and then texture player. Okay, so everything should be unloaded, all of our images, and let's quickly do the sound files. It's going to be very similar to what we did on the C side, and also what we've done here above with load and unload images. So self.resources resource type dot sound laser shoot equals, let's get that, move that over here. We are going to call pr.load underscore sound, and then assets laser shoot dot wave. And similarly for resource type dot sound laser explosion, we are going to call pr.load sound assets laser explosion. Okay, and then finally we call the reset function, which we had in the C version of our code. And let's go into our shutdown method and make sure we unload all of these objects. So we're going to be using pr unload texture and pr unload sound. So just for ease, I'm going to just cut and paste them. So here we're taking pr unload texture and then self resources resource type texture meteor small, medium large, and then player. There might be a way in Python to iterate through all of the keys in the dictionary and then call unload on those. But I thought since we have a mix of texture and sounds and they require different function names, like unload texture or unload sound, I thought it might be easier to just do these one by one. But feel free to experiment with that. Maybe if you're a Python expert and it's easy for you to iterate through a dictionary and call these individual function based on the value of the key, then go for it. Okay, so anyway, we've got our players, we've got our meteors clearing, we've got our textures and audio file loading up. And so let's draw our player and let's get that working. So in the render function, remember on the C version of things, we used a function called drawTexturePro. So we're going to be using the same thing. So we'll be calling pr.draw_texture_pro. And then we are going to be using the self resources resource type texture player. That's the first parameter of our function call. Okay, the second parameter, as you can see, is the source. So the source rectangle that we're drawing from. So we are going to be creating a PR rectangle at 0, 0, top left and right, and then self.resources resource type dot texture player dot width, and then a self.resources dot resource type texture player dot height. That's our second parameter, which creates that rectangle. Okay, and then the third is the destination rectangle. Okay, so similarly to the C version of this, we're going to be creating another rectangle. So PR rectangle, and we are going to be, for the X and Y of the rectangle, it'll be the position of the player. So self.player.position.x and self.player.position.y. And then for a width and height, we are going to be using self.resources and then resource type texture player dot width divided by 2. And then similarly, self.resources resource type texture player dot height. So the height of the image, double dividing lines divided by 2. Okay, so that is parameter 3. So now we need the origin. So where is our origin? We are going to pass in a vector2, pr.vector2, and we're going to be using self.resources resource type texture player dot width double divided by 4, sorry. And then I'm just going to cut and paste this. Self.resources at the index resource type texture player dot height double divided by 4. Okay, and then our second to last parameter will be the heading of the player, so self.player.heading, and then finally we'll be using pr.white, the color tint. Okay, so let's try this out. Let's go back to our console here and type in Python Main.py. Okay, and we see our image coming up here of our ship, which is a great sign. So let's go ahead and now work on the update code. And again, we're almost going to be copying this exactly as what we did in the C version of this. So let's clean up some of these. Okay, so first we're going to be looking for our is key down key presses. So if pr.is underscore key underscore down key left. So if the left arrow is used, then we want to self.player.heading minus 5.0. We want to subtract 5.0. If our PR is underscore key underscore down pr.key right, then we want to add 5 to the heading. So plus equals 5.0. Okay, and oops, that should be an elif. And then also an elif, PR is underscore key underscore down, PR key up, key underscore up. So if the up arrow is used, so we want to control the ceiling of our acceleration a bit here. So if self.player.acceleration is less than 1.0, then self.player.acceleration plus equals 0.04. Okay, so that should get our player spinning around and accelerating. And so let's update our position here. Let's calculate the updated positions. How do I? Okay, good. That's much better. Okay, so self.player.speed.x equals math, the cosine function of math, which is in the basic Python math library. But because of the underscore, we haven't imported it yet. We'll do it in just a second here. And we'll be using a NumPy function called degrees to radians, deg to rad, of self-player heading, because remember that the heading is just in radians. We want to convert it to degrees. And then we're going to multiply all of that by 6.0. And we'll do the same thing for the y. So speed.y equals math.sine, NumPy degree to rad, and then self.player.heading times 6.0. Okay, and then let's go back to the top here and let's just do those imports right now. So we can do all the math. So we want to import math, and we want to import NumPy as NP. And we're going to be using another one shortly called copy. So let's just take care of that now. So from copy, import copy. Okay, so we've got all the math libraries figured in. Okay, so we've got the math.cos and the math.sine. And now let's take care of the position. So self.player.position.x plus equals self.player.speed.x times self.player.acceleration. And then similarly, our y position is calculated by adding itself to self.player.speed.y times self.player.acceleration. And if you're new to Python, I forgot to mention this when we started, but if you're new to Python, the tab spacing is incredibly important. It's how it basically defines blocks. The Python languages define blocks. So in other languages, you would have, brackets like this, which would separate statements or blocks of logic. But Python doesn't make use of any of that. Instead, a colon is used to represent sort of a new block of code. So as you can see here, we've got the function definition and then a colon, and then the next line is 2 spaces into, or 1 tab into this, after this keyword. And so this tells Python that this is a block of code within this update function. You'll get used to it. If you're new to Python, you'll get used to it after working for it for a little bit. But for example, we can, just for an example, if we match the same alignment as the acceleration logic here, so if self.player.acceleration is less than 1, then what is going to happen with this code here, the way it's spaced? Okay, I will show you. I think you can guess, but I will show you. So let's run this right now. So Python Main.py. So we should be able to turn around, which we do. We can turn left and right, and we can move forward a little bit and turn, but then all of a sudden it doesn't work anymore and it feels weird. So why is this? Well, because what's actually happening here is because these blocks of code align with this statement, then Python is reading this all as within the same if conditional here, the if branch. So if while the acceleration is less than 1.0, then this logic will be executed. But once acceleration reaches 1.0 or above, then all of this will be ignored. And I actually ran into this while putting this project together and didn't realize that these blocks of code needed to be outside of the if of all of this key handling if stuff. Okay, so finally, let's do the bounds detection. So when we go out of bounds on the left or right or top or bottom, we warp in on the other side. And this is going to be pretty simple. We're essentially doing exactly the same as what we did on the C side. So if self_player.position.x is greater than self.screenWidth, then reset our position to be 0.0, our x position to be 0.0. If our x position is less than 0, then reset the position.x to be the screen width. And similarly to the screen height, if our player.position.y is larger than the screen height, then reset the player.position.y to be 0. And if the position.y is less than 0, then reset the y position to be the screen height. So let's quickly verify that. Okay, and again, we can turn around again, even though we're faster. Our acceleration is now higher, a little bit higher than 1. So if we go through the top, we can come up through the bottom, and if we go left, we can come out the right side. So that all looks good. Hooray! Okay. So far, so good. So let's get some meteors going. So in our reset function, what we're going to do is, after the player initialization, we're going to do the meteors. And so what I'm going to do is I'm going to create another for loop. So for I in range of max meteors. So remember how we had a constant called max meteors to be 20. So 20 is our maximum meteors. So let's just define that above here right now. So above game, just max_meteors equals 20. And then we're going to create another one for shots. So max shots. And I just came up with 5. But you can use any number you want here. So you can experiment with the 20 or the 5. Okay, so for this range, so basically what we're saying is from 0 to max meteors, which is 20. And so what we're going to do is we're going to create a new entity. So meteor equals entity. We're going to instantiate Meteor as a new entity, and then we're going to set the active flag to true. And now we're going to set the heading. So meteor.heading equals float, and then PR get _random_value 0 to 360. So we're going to create a random number between 0 and 360, convert it to a float, and then stick it in the heading variable. Okay, and our position is going to be very similar. So meteor.position equals pr.vector2. And then for the x component, we're going to use pr.get_random value from 0 to self.screenWidth. And cast it to a float. And then similarly, we are going to call pr.getRandom value from 0 to self.screenHeight and cast that to a float. Okay, and for a meteor type, which is like the size, so small, medium, large, we are going to call pr.getRandom value, and then our range will be resource type texture small up to resource type texture large. And then finally, let's come up with our speed. So meteor.speed equals pr.vector2. And for our x value, we are going to use, again, pr.getRandom value. So come up with a random speed between 1 and 2. And then for our y parameter, we're going to cast that to a float. And then for our y parameter, we're going to be calling pr.get_random random underscore value 1 to 2 and cast the result of that as a float as well. And with that entity object filled up, we're going to append it to our list. So self.meteors.append meteor. So we should now have about 20 meteors generated into this list. So let's go ahead and draw our meteors. And again, we're going to be using Draw Texture Pro. So before the player, I like to do everything before the player. We're going to create another for loop. So for meteor in self.meteors. Okay, so we're going to get a handle to the actual texture. So texture equals resource type. And then we're going to be referencing the meteor.type. Oops. And this will help us with shortcuts into Draw Texture Pro, which we could have done below here with player. So we could have created a texture equals resource type texture player and then referenced those things here. But I'll let you do that if you choose to go that route. So we're going to call PR Draw Texture Pro. And so we're going to be using the self.resources.texture. And then for our source rectangle, we're going to create a new rectangle. So pr.rectangle and then 0.0. And then for our width, we're going to be using self.resources texture.width and then self.resources texture.height. See, that's a little cleaner looking. And then for our destination, we're going to create another PR rectangle. So pr.rectangle. And for X and Y, we're going to be using the meteor.position.x and the meteor.position.y. Maybe let's put them on separate lines here. Maybe that'll make it easier to read. And then self.resources texture.width and then self.resources.height. Okay, so that should be the source and destination rectangles. Now let's do the point of origin. And let's use pr.vector2. And we'll be using self.resources texture .width double divides by 2 and self.resources texture at the index texture and then .height double divides by 2. And then we'll use for our float, for our rotation value, we'll use the heading, so meteor.heading. And then for our color tint, we'll be using pr. all capitals white. Okay, so that should go through all of the meteors in our array and draw them. When we called getRandomValue, we have to actually reference the value of texture meteor small. Okay, so we want to use the value of texture meteor small and the value of texture meteor large. Okay, so what we want to do instead with this texture is we're not referencing the index of resource type of, like, remember how I had the array square brackets here. Instead, these should be the round brackets because we're grabbing the value, we're grabbing the key given the meteor.type, which in this case, it will be something like texture underscore meteor underscore small, or between texture underscore meteor small and texture underscore meteor dot large. So we're grabbing the texture and let's run this now. Okay, so we can see that our asteroids, our meteors are there, and let's go ahead and update them. Okay, so after the player position code, let's run a for loop. So for meteor in self.meteors. Okay, so if meteor.active equals true, then the meteor.position.x we can use a plus equals meteor.speed.x times math.cosine numpy degrees to rad of meteor.heading. And we can actually, just for consistency, we'll move this over to the right. So meteor.speed.x. And similarly, meteor.position.y plus equals math.sine numpy degrees to radians of meteor.heading. And we're going to multiply that result by meteor.speed.y. And then we are going to do the position, the bounds detection, which will keep on the same level as this if, or underneath this if. And so here again, we've got, so if meteor position.x is bigger than self.screenWidth, then reset the position to x, position.x to x. If the position.x is less than 0, then reset the position.x to the screen width. If the position.y is larger than the screen height, then set the position y component to 0. And if the position.y is less than 0, then set the position.y to be the screen height. That should be all we need to do. So let's go ahead and run this again. Okay, we got meteors updating and they're wrapping around the screens properly. Excellent. So let's go ahead and work on the shots. Okay, so after all the keyboard handling here, let's add another one here. So if PR is key pressed, because we don't want to be able to hold down the shot key. We just want it, we want to take it one at a time. So PR.key left control. Okay, we'll use a colon there, and then we'll create a new entity. So shot equals entity. Shot.active equals true. And then shot.position.x equals, and then we're going to make a copy of self.player.position.x. And you have to make a copy because if you do this equals, then what's going to end up happening is we are linking the address of self.position.x. We're not assigning the value of this into shot.position.x. We're assigning the address. So in other words, whenever we then update the position of the player, it will then play havoc with the position of our shot. So instead, we just want to make a copy of it. So we want to make a copy of this value and use it for our shot position.x, which is what we're trying to do with this function. So similarly, shot.position.y equals copy self.player.position.y. Okay, and then we also want to copy the player heading. So shot.heading equals copy self.player.heading. And then we want to set our acceleration to 1. And then we want to calculate our speed. So shot.speed.x equals math cosine of numpy degrees to radians, and then self.heading, to self.player.heading, which is the same thing as our own shot.heading, but we'll just keep it this way, times 10.0, and then shot.speed.y equals math.sine numpy degree to rad of self.player.heading times 10. And then we want to append this new entity to the list of shot entities. So self.shots.append shot. And then we want to play that sound effect. So pr.play underscore sound, self.resources, resource type, sound laser shoot. Okay, so then let's draw the shots. So right after drawing the meteor, we can make the meteors, we can go into another for loop, for shot in shots. we can just draw a circle. So PR, draw a circle. And we're going to cast, we're going to call this shot.position.x and cast it to an int. And then similarly, we're going to create, for the center y, we're going to be casting the shot.position.y. And then for our radius, we're just going to be using 1.0. And then for our color tint, it will just be pr.yellow. For shot in self.shots, sorry. Okay, so let's go ahead and run this. Okay, so now we need to update the shots. So we've created the shot in this keyboard handler here. So now we need to update the shots. So after the for loop for the meteors, this is where I stuck. Remember to keep the same tab alignment. So what we're going to do here is for shot in self.shots. If shot.active equals true, if our shot is active, then go ahead and update the position. So shot.position.x plus equals shot.speed.x times shot.acceleration. And then similarly, shot.position.y plus equals shot.speed.y times shot.acceleration. And then if we go off screen, then we are going to turn the active variable to false. So if shot.position.x is larger than self.screenWidth or shot.position.x is less than 0, then we want to turn the active flag to false. Or similarly with the y, if our position.y is larger than the screen height or the position y is less than 0, then put the shot active to false. Okay, and then what I want to do is I wanted to write a filter function. So basically at the end of updating the meteors and the shots, instead of looping through both of these lists and then checking that active flag to be true or false, I thought which means that, you know, when you get to the end of the meteors, so when you've killed all of them, but maybe 2 or 3, that means you've got 17 of them that your update code is and rendering code is consistently going through checking if the active is true or false. So I thought a neat Python trick is we can use a filter function on a list. So basically at the end of the update cycle, we want to filter through all of the shots and all of the meteors lists, but take out only the ones that are active, and then set the list to be those values. And then that way, when we get to the render function, we don't need to do the check if our meteor or shot is active or not, if our entity is active or not, because we've already pulled out all of the ones that are no longer active from those 2 lists. Hopefully I explained that right. Okay, so I created a new variable here called active_shots, and we're going to call a filter function. And in Python, special function here called a lambda, which basically is like a function that we are throwing into this filter function. So lambda, I guess if I spelled lambda correctly, okay, so lambda x, so for each, and basically this function gets called on each item in this shots list. So for each item of the shots in this list, we want to check the active flag, and so we only want to return the ones that are true. And we're pulling it from the shots. Okay, and then self.shots becomes this list of active shots. So we only want to hang on to the shots that are active. And similarly with meteors, active_meteors equals filter, and then our lambda function will be, so for each item in that meteors list, x active equals true. So we only want to return self.meteors. We only want to return a list of all of the meteors with the active flag set to true. And then self.meteors equals list of active meteors. So convert the results of this filter function into a list that we can then use in the remainder of the render function. Hopefully I've explained that correctly. Okay. Our shots should be updating and clearing. There, we can see the shot now. Okay, so finally let's do our collision detection. So right before we filter out the active shots, let's go ahead and check the shot versus meteor. Okay, so for all of the for shot in self.shots, for all of the shots in the shots list, if shot.active equals true, okay, then let's go through all of the meteors. So for meteor in self.meteors, if meteor.active equals true. Okay, so the texture will be equal to resource type and then meteor.type. And then we can use the check pr.check underscore collision underscore circle function. So if pr.check underscore collision underscore circle function, and let's see, we're going to pass into it the shot dot position as the first parameter, and then 1, which is our radius, is it? Okay, it won't hover over the function call anymore. Okay, so 1, and then finally the meteor position, and then the radius of our meteor. So I'm just going to use self.resources texture.width and then double divides by 2. So if that equals true, oops, we don't need that. So if that equals true, then we've got a collision. Collision. So the hashtag is the comment flag in Python. Okay, so meteor.active equals false. So we want to now kill this meteor, and we want to kill this shot. So shot active equals false. And then we want to play the sound. Self.resources, resource type, and then sound laser explosion. And then we want to break from this for loop. Okay, so what should be happening here, if we put everything together properly, is that we're going to go through each shot in that self.shot. So remember how we've got, we're updating the shots, the active shots in our shot array. So if the only way that these will become inactive is if we pass through the bounds of the screen. So past the 4 sides of the bounds of the screen. And then so we're going to re-go through this array again, or this list. And then if our shot is still currently active, then we're going to, for each shot, we're going to go through all of the meteors in the meteors list. This is kind of a brute force collision detection algorithm. So we're going to go through all of the meteors in that self.meteors list. And so if the meteor is active, which it should be if it's in that list, but just for good measure, I'm going to double check it here. We're going to grab the texture of our meteor type. Then we're going to be calling the check underscore collision underscore circle function from the RayLib library, which returns a Boolean. So if there is a collision between the shot and the meteor, then return true. We can't do anything with, like, we can't remove an entity from the list that we're currently iterating through. Python won't let you do that, and many languages won't let you do that, so that's not really a big surprise. So we're going to instead turn the active flags to false for the meteor and the shots. Then we're going to play our sound effect for the explosion. And then finally, again, run through our filter methods to filter out anything that's dead in the shot or meteors list. Oh, and this should be check underscore collisions underscore circles. I wondered why it wasn't green. Okay, so there we go. So we're passing in the center of circle 1, and then a radius, which is 1 for the shot. And then the circle 2 center is the position of the meteor, and the radius is the width of that texture of the meteor, whatever meteor we're testing against. Okay, let's try this again. right. So that is pretty much all I have for this tutorial. I thought it would be a fun little way of converting the original Asteroids project from C code into Python using the RayLib Python bindings. I think it worked out really well. I'm actually pretty happy with how it looks in Python. I think I might do a little bit more Python. I haven't really been exploring too much of that. I didn't realize just how convenient it was to use this language. Put this all together in Python for you. The link to the GitHub repo is in the description of this video. Please download it, give it a shot. I hope you really enjoyed it. Leave a comment down below. Like the video if you want to see more of Python code. And I'll see you in the next one, folks. Peace.